Okay, let's look at this question. So this is a variation of time of speed of car A and B. They want to find what is the distance between the car A and B when time equals to 14 seconds. So over here. So the concept applied is the displacement area under velocity time graph. But anyway, take note that at time equals 0, car A passes car B means that they start at the same point when time equals to 0. Distance by car A is this orange area, so it's just simply 20 times 14. Okay, so 280. Distance by car B is this blue triangle, so it is 0.5 times 10 times 20. So 10 is because it's from 14 to 4 to 14. Okay, so and 20 is of course this. Subsequently, this is the value, and the distance between A and B of course is just subtraction, and it's 180 meters. For part C, we'll divide the motion into various parts. From 0 to 4 seconds, the distance from A and B is increasing because B is stationary while A is moving. 4 to 14 seconds, the distance between A and B is still increasing, but at a slower rate as B is still slower than A. But from 14 seconds onwards, distance between A and B is decreasing as B is now faster than A and is catching up. Okay, another question. Okay, take some time to read the question. So the first question asks you to sketch a velocity time graph in terms of t, okay, for the above. So what happens is that this guy accelerates uniformly from rest, meaning velocity equals 0 for the first t seconds, and reach a velocity of 10 meters per second. Then after that, he maintains his velocity for the rest of the race, and the timing for race is this. So sketch means that you just draw a line. In this case, it's accelerate uniformly from rest, and the value is 10. He reached 10 meters per second, and the time that it reaches t. And maintain this velocity for the rest of the race till after when it ends the race at t equals 12 seconds. So this is the answer. B. Form an equation to calculate the value of t. We know that this is a 100-meter race, so the area under the velocity time graph must be equals to 100. So, and the area is A and B. So 100 meters must be equivalent to area A, which is a triangle. It's half times base times height in terms of t, and area B also is just base times height. Okay, so this is actually t minus 12 minus t. So by simplifying, you would be able to get t equals to 4 seconds. Part C, using the values of t, calculate the man's acceleration. So acceleration is just final velocity minus initial velocity divided by time taken. So by substituting the various value, you should get 2.5. And calculate the distance the man run before reaching his maximum speed. Is simply just the distance is required is area A, and just find area A, which substitute in the t equals to 4, and you should get 20 meters. Okay, the last question. Some prior knowledge needed. Acceleration of free fall is 10 meters per second square, and in rounding error this means that all objects will fall at the same rate, so it doesn't matter whether it's a book or a pencil. So first thing, I would suggest you sketch the velocity time graph of the objects. It will make the question much simpler. So it's just simply like this, okay, because it's falling under 10. So, and t is the time when the object hits the ground, and v is the velocity before they hit the ground. So something along like that. Okay, so to solve part, how long does the object hit the ground? So what you need to do is the acceleration of free fall is equals to final velocity, and then just substitute in the value. Okay, you get v over t, and thus just express v in terms of t, and label this as equation 1. And we know that the object fell 9 meters before it hit the ground. Again, thus area under this velocity time graph, which is the area under the triangle. So by substituting in, okay, you find that area of triangle is just in terms of bt is 0.5 times base times height. Okay, so your base t and your height b. And of course, from 1 we can substitute in the value of b equals to 10t, and this is of course 5t squared. Okay, sorry, this is 5t squared. And by solving for t, you get 1.34 seconds. So this is the answer for part A. For part B, just sub into equation 1, where v equals 10t, and you should get 13.4 meters per second. Okay, so that's all for now.
Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteachers.wordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.